In this video, we're going to look at how to solve a linear equation by using a table. So we have four equations over here, and you see some similarities between these equations. And certainly you could solve all of these equations algebraically by isolating x on one side of the equal sign. But that's not really the purpose of this video. This video is to think about the equation y equals 0.5x minus 2.5, the linear equation, that graph. Create a table of values and see the relationship between these table of values and these equations. So I've started a couple over here, but I want us to generate these to really think about the pattern of what's happening here. So remember, the key characteristic of a linear equation is that it has a constant slope. And you may know how to find the slope of a line by just looking at the equation, and if you do, that's great. But we're going to go over how to do that looking at the first couple values of the table. So now these values in the table were simply generated by plugging in 3 for x. So 0.5 times 3 is 1.5. Take away 2.5 would give me -1. And if I put 2 in for 0.5, I get 2 in for x, I get 2 times 0.5, which is 1. Take away 2.5, which is -1.5. Now we could continue plugging in 2 for x and generating the table, but we're going to work a little smarter here, and we're going to think about what's happening as far as our rate of change. So we see that when x went down by 1, all right, we went from 3 to 2, so x went down by 1. What happened to the y value? All right, it went down by 0.5. So because this is a linear equation, we know that our slope is the change in y. I'm going to use this triangle symbol, delta, to mean the change in y over the change in x. So we see in these first two ordered pairs, the change in y is -0.5, and the change in x went down by 1. And if I divide these, I simply get positive 0.5. And those of you that know how to find the slope of a line in the equation already saw that that slope was going to be 0.5. All right, so what that means is every time x increases by 1, y will increase by 0.5. If x decreases by 1, let's say we go down to 1, then y is going to decrease by 0.5. All right, we're going to get this constant rate of change. Constant rate of change. All right, so if I let x go down 1 more to 0, then y is going to go down 0.5. Down 1, down 0.5. Down 1, down 0.5, etc. And you could fill this out as long as you like. And we could go ahead and verify. Let's verify the -3. So if I plug -3 into this equation, 0.5 times -3, take away 2.5. 0.5 times -3 is -1.5. Take away 2.5 is -4. All right, but we didn't have to go through all that computation. Following the pattern was much easier. All right, so now let's take a look at these equations. And we see that in the y spot, all right, in this spot right here, we have -2. Notice that the stuff on the other side of the equation here, this 0.5x minus 2.5, is the same as this. So I'm trying to find the value of x that will give me an output of -2. So I want to look at my output, which is in the right-hand side of the column. There's the -2. So the value of x that will produce an output of -2 is 1. Now, you want to go solve this algebraically to verify that? I think you should. Add 2.5 to both sides, divide by 0.5, you're going to get 1. And maybe you can kind of see that just by looking at it. All right, pause the video, try the next one, and start the video when you have your answer. In this case, our output is -1. So I want to go over here in my right-hand side, my outputs of my table, and find where the output is -1. The input that produces that output is 3. So x equals 3 is the answer. All right, the next couple are a little bit trickier because the output does not appear on the table. So the next one, we have 0.5x minus 2.5 equals 0. All right, and if I look over here in my output side, I don't have 0. So I have to think about where 0 would be based on the pattern that we saw. So if I wanted to get 0 in this column, I can see my outputs are sort of getting bigger as I go up. So if I found let's extend this table up here. Let's say I let x be 4. All right, then the y value would go up by 0.5. And so that would be negative 0.5. All right, so if I let x be 5, y would be 0. So there's our answer, x equals 5. So the point of this example is to show you that if you're trying to solve an equation with a table, the answer that you're looking for, the output you're looking for, might not be in the table, but you can extend the table, especially if it's linear, very easily to find the desired output. All right, why don't you try the last one on your own, pause the video, unpause it when you're done. So in this last one, we're looking for an output of negative 4.5. I look at my table, I'm pretty close here. If I just go one more, this y value will decrease by 0.5. That'll give me my negative 4.5 I want. I have to decrease the x value by 1, which is negative 4. So there we go. I have my answer. The x value of negative 4 will give me the output of negative 4.5. And again, you could certainly verify this is the solution by plugging it in. Negative 4 by plugging it in or solving it algebraically, or even looking at the graph. All right, I hope that helped you think about how the table relates to the equation and also relates to solving linear equations.